1998, number 87. So we want the equation of the line tangent. I immediately do this because this is the equation of any line at the point where, so it's touching the line where the slope of the tangent line is 1 because the derivative tells us the slope of the tangent line. Well, if the slope of the tangent line is 1, I already know that this slope is going to be 1. So all I have left is finding the point of tangency. Where is it touching where the derivative equals 1, right? So the derivative is 4x cubed plus 4x. All I did was take the derivative of that, right? And I want to know where that equals 1, because the place where the derivative equals 1 is the point of tangency I want to use, okay? So I'm going to graph this, graph that, and set it equal to each other. If you want to be even safer, there's another way you can do that. So I will show you a safer way just to avoid a careless error of taking the derivative wrong and messing up. So what we could do, go back to our y equals, and put in the original function, okay? X to the 4th plus 2x squared. Now, I wouldn't do this. I would just take the derivative. It's a pretty easy derivative. The chances of making a mistake are pretty slim, but I want the derivative. Now, I told you earlier you can store it as y8. This is erased it, so I'll put it here. I want the derivative of y1, so I'm going to do math 8 with respect to x of y1 at all values of x. Now, I don't want to graph the original function, so I'm going to unhighlight the equals. So I'm only graphing the derivative, and I want to know when the derivative equals 1. Okay, now let's go back and see what our possible choices are. Now, okay, so looking at this will be the biggest positive value, 2, the smallest, negative 1-ish. I'm just going to go negative 5 to 5, just to be safe. You know, if you can't see where it equals, then no big deal. But I'm going to go from negative 5 to 5. Now, if you don't see it cross, you just go wider. I want to know when it equals 1. So technically, I just have to go from 0 to 2 so I can see where it equals 1. There it is. I can see where it intersects. So I could do second calc. Now, let's go back. Maybe you want to see more of this graph, so I could do zoom 0, which will make it fit better. Okay, part of the problem is you're asking where did that second graph go? Y equals 1, y3, it's black. Why don't I see it? It's actually so close to the x-axis you can't see it. So what I mean, let me show you. That line's there. It's just the scale, it's just right there. You can't even tell. But you know they intersect about here. So we're going to be safe on that. So we can go second calc intersect and pick a point to the left. That's definitely left of the intersection point. Pick a point to the right. That's definitely to the right of the intersection point. Oh, I'm sorry. That's not what I'm supposed to be doing. The first one asks, is the red graph my first graph? So enter yes. Is the black one my second? Enter yes. Now I'm going to guess. And the answer comes out to be 0.2367. Do you see that? And y equals 1. 0.2367. 0.2367. So 0.237. So this happens at x 0.237 and y equals 1. Well, we knew y equals 1 because we didn't. Sorry, my bad. I'm a liar, pants of fire. 0.23667 is the x value, right? Now I need the y value. So what is y of the original function? Well, of the original function, where is it? It's y1. So I want to know y1 at, oh, I didn't save it. Okay, hopefully, okay, I'm going to have to go back and find the intersection because I didn't save that. So intersections at x, right? So I'm going to do x store a. Now I've stored that as a. Now I want to find the y value of the function. So I'm going to get the y value at a, 0.115. 0.115. So it's going to be y minus 0.115 equals x minus 0.237. And then they just simplified by adding this to both sides. So if I take 0.237 negative and add 0.115, 0.237, this should be negative. We add 0.115, I get negative 0.122. So it's going to be minus 0.122, and there's our answer, D.